In the shadow of fast-moving semi-trucks across the highway hides a technological masterpiece that controls their immense power: air brakes. Before we dive into air brakes, let's go back in time and explore the history of braking systems. From ancient chariots to horse-drawn carriages, people have always been obsessed with finding ways to stop their vehicles. But it wasn't until the rise of the industrial age that things really started to get interesting. Throughout history, the development of braking systems has been a crucial aspect of evolution in the transportation industry. From primitive methods used in ancient times to the advanced technologies of the modern era, the search for effective braking systems has been driven by the need for safety, control, and efficiency. Let's take a journey through time to explore the fascinating evolution of braking systems. In the early days of human civilization, braking systems were simple and often relied on physical mechanisms such as friction and leverage. As time progressed, the sophistication of braking mechanisms also grew. In the Middle Ages, horse-drawn vehicles and ancient chariots were equipped with hand-operated mechanisms that pressed blocks of brake pads against the wheels. The introduction of early mechanical connections provided more precise steering and improved braking power. The industrial era marked an important turning point in transportation history. With the rise of steam-powered locomotives and the expansion of railroads, the need for reliable braking systems became paramount. Engineers faced the challenge of developing brakes that could handle the enormous weight and speed of trains. One of the most significant moments in the evolution of braking systems was the invention of air brakes by George Westinghouse in the late 19th century. Westinghouse's revolutionary system used compressed air to distribute braking force, allowing multiple railcars to be brought to a synchronized and controlled stop. This innovation dramatically improved safety and efficiency in rail transportation. In the automotive industry, hydraulic braking systems became the first choice, using fluid to transfer force from the brake pedal to the brake components. Introduced at the beginning of the 20th century, this innovation significantly improved braking efficiency and reliability over earlier mechanical systems. In the middle of the 20th century, however, another groundbreaking development occurred: the introduction of disc brakes. This innovation not only provided superior heat dissipation, but also took braking performance to unprecedented levels, surpassing traditional drum brakes. In the last part of the 20th century, anti-locking brake systems were introduced, which prevent wheels from locking during hard braking, improving steering control. As technology advanced, electronic systems integrated sensors and computer control to improve braking performance and stability, leading to the development of electronic stability control and more advanced safety features. The evolution of braking systems continues into the 21st century. Innovations such as regenerative braking in electric vehicles, which converts kinetic energy back into electrical energy, illustrate the ongoing quest for efficiency and sustainability. Before we look to the future, let's go back to the 19th century, when George Westinghouse introduced a compressed air system to control the brakes of trains. This pioneering technology later found its way into semi-trucks and contributed to the evolution of modern braking mechanisms. But how do air brakes work their magic on modern trucks? Air brakes work their magic on modern trucks by using compressed air as the powerful engine behind the braking process. When a driver depresses the brake pedal, a complex network of valves and pipes are actuated, releasing compressed air and distributing it to brake chambers at each wheel. In these brake chambers, air pressure pushes against special pistons, which in turn press the brake linings against the rotating wheels. This generates friction and gradually reduces the speed of the truck, resulting in a safe and controlled stop. The crucial element here is air pressure, which is converted into mechanical movement and braking force. This advanced technology ensures that each braking action is evenly distributed to all wheels, keeping the truck stable and manageable, even with heavy loads. Using air as a power source provides precise control over the braking process and minimizes the risk of wheel slippage during braking. Now that we know how air brakes work, let's look at their benefits and challenges. Air brakes provide consistent and reliable braking performance even under heavy loads and prolonged braking. This increases road safety and minimizes the risk of brake overheating. In addition, the air pressure system distributes braking force evenly to all wheels, improving truck stability and controllability. This prevents wheel lockup and minimizes the risk of skidding during braking. There is also generally less friction and wear on air brakes compared to other braking systems. This extends the life of brake components and reduces the need for frequent replacement. Because air brakes require less physical effort to operate compared to hydraulic brakes, this helps reduce truck driver fatigue, especially on long trips. Besides, air brakes make it easy to transfer braking power from the truck to trailers. This allows for stable and controlled braking even when multiple trailers are towed. Along with these benefits come challenges of air brakes on modern trucks. Although air brakes are generally robust, they require regular maintenance and careful inspection to ensure optimal performance. Leaks, blockages, and other defects can affect system performance. In addition, the air pressure system of air brakes is complex and requires specific knowledge and skills to understand and maintain. Insufficient knowledge can lead to inefficient braking and potentially dangerous situations. The initial installation and maintenance costs of air brakes can also be higher than some other braking systems. This can be a financial consideration for transportation companies. In some situations, such as downhill driving, air brakes can build up heat and increase the risk of fading. Drivers should take precautions to prevent overheating. Although air brakes are already advanced, they sometimes need to be supplemented with additional technologies, such as ABS, to ensure maximum safety. Maintaining air brake systems requires finesse and expertise. Regular inspection and maintenance of semi-truck brakes is critical to ensure the safety of the driver, the vehicle, and other road users. Adequate care and attention to brakes contribute to optimal braking performance and reduce the risk of brake failure and accidents. Air braking systems in trailers play a crucial role in improving road safety. Statistics show the significant impact of defective air brakes on truck accidents and the importance of addressing this problem to reduce accidents and improve overall safety. According to Transport Topics, a faulty air brake is a contributing factor in nearly 30% of truck accidents involving semi-trailers. This emphasizes the importance of maintaining and properly operating air brake systems to prevent accidents. There are two main ways air brake failures can occur: system failure and truck driver error. In the case of system failures, if the supply of compressed air to the braking system is blocked, it can cause the brakes to lock up and the driver to lose control. On the other hand, truck driver mistakes, such as over-reliance on air brakes while driving downhill, can also lead to brake failure and accidents. This highlights the importance of proper truck driver training and implementation of safe driving practices. Furthermore, research shows that as many as 51% of commercial vehicle brake system failures are related to the air brake subsystem. This underscores the need for consistent maintenance and inspection of air brake systems to identify and address potential problems before they lead to accidents. The application of advanced safety technologies in large trucks, such as lane departure warning systems, automatic emergency braking, and air disc brakes, can prevent a significant number of truck accidents each year. These technologies can help reduce accidents caused by brake failure and other factors. Regulations and standards play a crucial role in the development, acceptance, and safety of air brake systems in trailers. These regulations ensure that air brake systems meet specific criteria and standards to ensure the safety of drivers, passengers, and other road users. Federal Motor Vehicle Safety Standards. The National Highway Traffic Safety Administration establishes and enforces federal motor vehicle safety standards that apply to various aspects of vehicle safety, including air brake systems. For example, FMVSS 121 describes requirements for air brake systems and covers components such as brake hoses, brake fluid, and brake performance. These standards ensure that air brake systems meet minimum safety and performance requirements. Besides that, you have the Commercial Vehicle Safety Alliance. The CVSA is a nonprofit organization that works to improve the safety of commercial motor vehicles through uniform enforcement and inspection programs. They host the annual Brake Safety Week, during which commercial vehicles are inspected to ensure compliance with brake system regulations and standards. This initiative helps identify vehicles with brake-related problems and ensures that they are addressed immediately. Air brake systems may also be subject to international standards and regulations. For example, the International Organization for Standardization may have standards that apply to certain aspects of air brake systems, contributing to their standardization and compatibility in different regions. Research and academic studies, such as those presented in the journal article, explore ways to optimize air brake systems for improved stability and performance. These studies contribute to the continuous improvement and innovation of air brake systems, which can then influence industry practice and regulations. Government agencies responsible for transportation and traffic safety, such as the U.S. Department of Transportation, work with industry stakeholders to create and update regulations for air brake systems. These agencies also conduct research and collect data to inform regulatory decisions. Air brake systems unfortunately also impact the environment, and their contribution to fuel efficiency and lower emissions is becoming increasingly important in the context of sustainability. When brake components such as disc brakes and brake pads wear out, particles can be released into the air, also known as emissions from brake wear. These particles contribute to air pollution and negatively impact air quality and human health, especially in urban areas. Electric vehicles use regenerative braking, which recovers and stores energy during braking. This reduces reliance on traditional friction brakes and minimizes emissions from brake wear. As a result, EVs are more energy efficient and have lower particulate emissions, contributing to cleaner air and a better environment. Innovations in braking technology, such as energy recovery braking systems, strive to reduce the environmental impact of brake wear. These systems use electric generators to replace or supplement mechanical braking systems, resulting in less brake wear. By converting braking energy into electricity, these systems offer an environmentally friendly solution while maintaining braking performance. Reducing the weight of brake components, such as air brake systems, can improve overall vehicle efficiency. Lightweight braking systems contribute to lower energy consumption, improved fuel efficiency, and reduced greenhouse gas emissions. More efficient brake components and innovations in pump technology contribute to more sustainable transportation systems. Some companies are working on green product development, including air brake systems. Weight reduction of air brake systems can result in lower fuel consumption and emissions. In addition, innovations in pump technology, such as energy-efficient oil pumps and electric pumps, can contribute to more fuel efficiency and reduced environmental impact. The future of air brakes in the truck industry promises continued innovation and improvement in safety and performance. While air brakes have long been an essential component of heavy-duty vehicles, there are some exciting developments and trends that are paving the way for the coming years. Consider digital integration, for example. Modern vehicles are becoming increasingly digitally integrated, and this includes brakes. Future air brakes may incorporate advanced sensors and electronics that can collect and analyze real-time brake performance data. This will result in improved monitoring, diagnosis, and even predictive maintenance of the braking system. Moreover, smart braking technologies are expected to evolve, allowing trucks and drivers to be even safer on the road. Forward-thinking systems can automatically react to speed changes, traffic conditions, and emergency stops, significantly reducing the risk of accidents. The future of air brakes is also likely to focus on improving overall efficiency and sustainability. This could include systems that recover energy during braking, reducing fuel consumption, and lowering operating costs. With the advent of self-driving vehicles, air brakes are likely to be integrated with advanced autonomous systems. This integration will result in seamless cooperation between brakes and autonomous driving, contributing to safer and more efficient freight transportation. Ongoing innovations in materials and construction techniques can lead to lighter and more durable brake components. This will not only improve overall performance, but also contribute to fuel efficiency and reduced wear. In the future, air brake systems may have self-diagnostic capabilities that detect and report problems before they become severe. This could lead to reduced downtime and more efficient maintenance. With a growing global cargo industry, there may be more focus on international standardization of braking technologies. This would result in uniform standards and guidelines for air brake systems, which would improve safety and compatibility on an international scale. In summary, although air brakes are a long-established and proven technology, their future is filled with promising developments. Through continued innovation and integration with emerging technologies, the next generation of air brakes will continue to be safer, more efficient, and advanced freight transportation on tomorrow's roads. If you liked this video, don't forget to hit that like button, subscribe, and ring that notification bell to stay up to date on all things trucking. Until next time, keep on trucking and stay safe on the road.